Okay, now this is going to be the rest of the homework, starting with question 6, where we're told to find F, circle G, and G, circle F. In this problem, we're told that F is equal to 2 times the square root of 3. Excuse me, I'm getting ahead of myself. 2 times the square root of x plus 3. And g of x is equal to x squared plus 1. Okay, so let's start out by looking at F circle G, or F composed with G of x, which we can read from left to right as saying F acting on G. So the one on the right is going to be on the inside, and that means that we're going to say F is going to apply to G. Well, what is G? G is just x squared plus 1. So F is going to act on G. And what does F tell us to do? Well, F says, and I should have wrote this a little better, this as f of x so take the function f of x says take whatever your input is, put it underneath a square root, multiply by 2 and add 3. So that's what we're going to do. We're going to say 2 times the square root of whatever the input is plus 3. See, I just copied over what the function x is, and now I'm going to put in what g is. It's x squared plus 1. Okay, so now the only thing left for me to do is possibly simplify this. If what's underneath the square root sign is a perfect square, then I could go ahead and factor that. And we know a square root cancels out a perfect square, and then we would just have x squared. We would have the remaining factored, the factor out. The problem here is this is a sum of 2 perfect squares, which we know is prime. Remember that we knew this was prime because it's a sum of 2 squares. It's an a squared plus b squared form. So we know we can't factor that. So really we are done at this point. This would be our answer. And then the only other question we need to consider is the domain. So we know we have to ask about 2 questions. Is there a square root? And yes, there is. So the domain says that the x squared, the restriction due to the square root is that whatever is under the square root, so here the x squared plus 1, has to be greater than or equal to 0. Now, we know that this is prime, so we don't have a solution, and therefore we don't even need to bother with trying to use the quadratic formula or factoring it. But when you look at this, I also want to help you get some intuition. This is x squared. It's always positive. And now we're adding something else to it, plus 1. So really, everything on the left always is going to be greater than 0. Right? This is always positive. So therefore, the domain, there's no restriction that we need to state, because we always will meet this condition for negative infinity to positive infinity. So the domain is just negative infinity to positive infinity. Okay, so now let's do part B of this problem, and that is G circle F of x. Okay, so same thing. G acting on f of x is equal to G acting on 2 square root of x plus 3. And what is that? Well, G says take whatever your input is, square it, and add 1. So take whatever your input is. So I'm going to do parentheses, square it, and add 1. Right? This is my input. That's the part that I'm leaving blank because I'm going to fill it in with what G is, with what the input is, which is 2 square root of x plus 3. All right, next thing. So now we've done the new part. We've set up the new part. Now we go back to the stuff we've been practicing since the first section, topics 1 through 7, which is now we got to go ahead and multiply this out and simplify it. So we're going to first just write out what it is. 2 times the square root of x plus 3 times 2 times the square root of x plus 3. And we can't forget to bring that plus 1 along. So we're going to use FOIL, or the distributive property. So the first times 2 times the square root of x times 2 times the square root of x is going to be 4 times the square root of x squared. All right, so I'm really hoping you're starting to see that that is going to cancel out. Now outer, we have 3 times 2, or 6 square root of x. Inner. All right, so I did this one, and now I'm doing this one. 3 times 2 times the square root of x, and that's going to be another 6 square root of x. And then finally the last, so 3 times 3. So here's where we're going to get our plus 9, and we still have the plus 1. So this all together comes out to 4x, because that square root is canceled by the squaring, right? They're inverse functions. One undoes the other. And here we have 2. We have like terms, so we're going to have a total of 12 square root of x. And then in the end, we have 2 numbers that we add together to get 10. Okay, so we have a different form than what we had before. If you remember, when we did f circle g, we have 2 times the quantity square root of x squared plus 1, and then an addition of 3 on the end of that. And here now we have a very different looking function. If we wanted to, we could probably pull out of this. We could factor it, but it's fine to leave it like this. This is fine. The only thing we do need to answer the question about is the domain. So if we're talking about domain, here we ask the question, is there a square root? And yes, there is. So we see that there's a square root. So we got to take whatever's underneath that square root and make it greater than or equal to 0. So that becomes our domain. And you remember, in order to write that in interval notation, you can set it up on a number line if that helps, or you can go straight away to 0 to infinity. So here's our whole answer. Okay. That takes care of 6. So now let's look at 7. Seven says, find each of 2 where h is equal to g circle f, and f of x is equal to x squared plus x plus 1. And g of x is equal to x squared. Okay, so if we're going to solve this, the first thing we're going to need to do, obviously, is get h, which is g composed with f, or g of circle f. So let's start out by doing that. So let's get h of x. That is g circle f of x, which we know is g acting on f of x, which is g acting on x squared plus x plus 1. And what we're told is that what g says is just take whatever you get and square it, right? So we're just now going to follow this directions, which says take your input and square it. And here our input is x squared plus x plus 1. So this actually I can do by applying the distributive property very carefully. It would be long and it would be messy, and sometimes that is exactly what I would need to do. In this particular case, we're asked to find H2. So instead of going through all that long derivation, I think it's much easier and smarter to just go ahead and stick in the 2. So let's do that. So we're going to have 2 squared, right? So now I'm putting in 2 everywhere there was an x, plus 2 plus 1, and we're going to square that. So here we're going to get 4 plus 2 plus 1 is 3 squared, and that's 7 squared, and 7 times 7 is 49. So that's our final answer. The next question says to find f of a plus h minus f of a divided by h, where f of x is 2x squared plus 1. And by the way, this also, we have a condition that h is not 0. Okay, so this is going to be, we're going to write using the definition that we see for what f of x is. We're going to go ahead and include that here. So we're going to have f of a plus h. So we're going to go 2a plus h squared plus 1. Okay, so that is this part. Okay, now we're going to subtract f of a. So I'm going to put parentheses around f of a because I want to make sure I don't mess up that negative sign and somehow forget it or drop it. So what's f of a? Well, f of a means I just put a everywhere there's an x. So that is just 2a squared plus 1. And then this whole thing is divided by h. So just to make our writing a little less cumbersome, I'm going to pull out the 1 over h, right? Because division by h is the same as multiplying by 1 over h. So I can now work on what's over here in the numerator. So the first thing I'm going to do is I'm going to put parentheses, and then I'm going to say 2 times a plus h times a plus h. And then we're going to add the plus 1. And now we're going to distribute this minus sign to each term in the second factor. So that's going to be minus 2a squared minus 1. All right, so now it's just a matter of doing the algebra of simplifying. Well, actually, we still need to distribute the a plus h times a plus h and multiply that out. So let's say that's 2. I'm going to put parentheses around the whole thing. So I have an a squared from the outer, and inner a, first gives me a squared. Outer is ah, another ah, and then an h squared. So that's plus 2ah plus an h squared. And then I see that plus 1 is canceled with minus 1, and I have a minus 2a squared to bring along. Alrighty, next, let's keep on going. So this is 1 over h times, now let's distribute this 2. We have 2a squared plus, right, 2a squared Okay, so we have to distribute the 2a squared. We're going to multiply it by each term in this factor. So we end up with a 2a squared, and 2 times 2 is 4ah plus 2h squared. And then we bring along the minus 2a squared. Now notice that 2a squared and minus 2a squared cancel. Okay. And what we're left with is 4ah plus 2h squared, all over h. And notice we can pull an h out of that, so that it's h times 4a plus 2h, all over h. And h over h is 1. That's a disguised form of 1. Those would cancel out. And we're left with 4a plus 2h. And we could factor out a 2, but we don't need to. This is sufficient for a final answer. The next group of problems are word problems. So for this, we're going to look at those word problems. The first problem says that TMI is a manufacturer of blank thumb drives and has a monthly fixed cost of $12,100 and a variable cost of 60 cents per drive. We're going to find a function C that gives the total cost incurred by TMI in the manufacture of X thumb drives per month. Alright, so we're going to need to put the fixed cost of $12,100. So, okay, that's problem number 9. So let's go ahead and start setting it up. We are told that we have a fixed cost of $12,100, and we have a variable cost. I'm making a movie, so now I have to start again. That's okay. And we're told, I can clip it out, we're doing a variable cost of 0.60 cents per drive. So we put that's our unit price of 60 cents and times that's the cost for each one, and X is the number of them that we have. So putting this together, we see that in order to find a function for the cost that TMI incurs, it's going to be the fixed cost plus the variable cost. And actually, we generally put things with variables like X first. So let's say it's the variable cost plus the fixed cost, because that'll start putting it more in the linear equation y equals mxb form that we're used to seeing. So let's go ahead and write that out. So it's 0.6x plus 12,100. And that is our cost function, made up of a variable piece and a fixed piece. Okay, let's go ahead and find out what problem number 10 said. It says, suppose the fatality rate or deaths per 100 million miles traveled of motorcyclists is given by G of X, where X is the percentage of motorcyclists who wear helmets. And then next, suppose that the percent of motorcyclists who wear helmets at a time T is measured in years, is F of T, where T equals 0 corresponds to 2,000. Okay, wow. We got to write all this out to keep it straight, I think. But now we have, it says if F of 0 is 0.64 and G of 0.64 is 26, find CF circle G of 0 and interpret your results. Okay, let's slowly put this together. So we have, let's put this together. So we're told that the fatality rate is G of X. So this is the fatality rate. Is given by g of x, where x is the percentage of motorcyclists who wear helmets. So this input is the percent of motorcyclists. I should just say bikers so it's easier to write. Cyclists with helmets. Okay, then we're told that the percentage of motorcyclists who wears helmets at any time t is given by f of t. So f of t is the percentage of bikers with helmets at time t and we're told a little bit more information, that t equals 0. So t is given only in terms of whole years, and it corresponds to the year 2000. So, okay. All right, so now what we're going to do is we're told what happens, what we're told now is that f of 0 is equal to 0.64. Okay, so first of all, let's think about what that means. That means in the year 2000, because t equals 0, right? So time is what the input is. I should say time is, and that corresponds to 2000. There was 0.64, or 64% of bikers wore a helmet. Okay, now what we find out is that we put this number, so we're going to be looking at G composed with F, all right, and that starts out at our initial function. So G is going to act on the 0.64, and we're told that that is equal to 26. So I should have said this was t equals 0 back here. T equals 0 gave us the 0.64 because I'm just copying that over. So t equals 0. All right, so what is G of 0.64? We find out that it's equal to 26. Okay, so the way we would interpret this is we would say in the year 2000, there is a total of 26, and what's our output from G? Let's go back and read that. It said that it was the output on G. What does G give us? It gives us the fatality rate, or the deaths per 100 million miles traveled. Okay, so that means that we have 26. So to interpret it, we have 26 deaths amongst bikers who wear helmets, right? Because that's our input, was motorcyclists with helmets. So of 26 deaths of bikers with helmets. So I should say in the year 2000, this model estimates 26 deaths for bikers with helmets for every 100 million miles traveled. Okay, and who is the 100 million miles traveled by? It's traveled by these bikers with helmets. And that is how we interpret that. Okay, so that was part A. Okay. Part B says, now suppose that we have f of 6 and it equals 0.51. And then g of 0.51, notice that we can put these functions together because the output of f is the input to g. So we're linking right there, right? And so now we're looking at, actually the typo was above. This above on A had said to do F circle G, which is impossible because F has to act on time and the output of G is a death rate. So there was a typo in A, it should have been G circle F. So apologies about that. Anyway, so here we're fine. G circle F of X is what we need to do. So we're going to say that G circle F at time 6 means we're going to do G of F of 6. Well, F of 6 is 0.51, so that's G, right? We're just going to use this to make G of 0.51. And then that is going to equal, sorry, we were told this earlier. That's what I meant to write, that this is equal to 42. So now we say, okay, G of 0.51 is 42. So what is that telling me? Well, it's telling me that in the year 6 after 2000, so that's in the year 2006, according to the way we were told that f of t, that they were setting t equal to 0 for the year 2000. So this has to be 6 years later. It's 2006. So we should say that in 2006, there is estimated to be 42 deaths of bikers who wear helmets, for every 100 million miles traveled. Now we're going to go and look at problem 11. Let's read what that says. So that says that a division of Chapman Corporation manufactures webcams, and the weekly fixed cost for the division is $20,000. The variable cost for producing X webcams a week is given by this complicated function that involves many zeros and a 1 times x cubed minus 0.01 x squared plus 50x dollars. And then the company realizes a revenue of negative 0.02 x squared plus 150x dollars for sales of X webcams per week. And this has a capacity, a maximum amount that this revenue function is thought to be applicable up to 7,500 webcams sold. So we're asked to first find the total cost function, then the total profit function, and then what is the profit for the company if 2,000 units are produced and sold each week. So let's start out with the cost function. The cost function is going to be, remember, a combination of fixed and variable cost. So If I look here, we have a fixed cost. I'm not able to draw on here. A fixed cost of 20,000, and then the variable cost is given by this function. So let's put that over into our expression for the cost function. Because remember, we're going to have the cost function equaling the fixed cost or the variable cost plus the fixed cost. Okay. So let's put the variable cost, the cost function is the variable cost, which was 0.12345 ones after the decimal, x cubed, minus 0.01x squared, plus 50x. Okay, so this is all the variable part that we were given in this function, in this description of this problem. And then we're told to add, then we're told that the fixed cost is 20,000. So we're going to need to add in the fixed cost. Then we're given a revenue function. And the revenue function is minus 0.02x squared. Should be a little zero in front of the decimal to be clear, plus 150x. And we're told that x has a capacity of 7,500. Or that this revenue function is applicable over an amount of webcams per week of 7,500. Okay, so first of all, we found the total cost function, so this was A. And there was no combining any terms here, because this was x cubed, x squared, x, and then a constant. B, find the profit function. Okay, so the profit function is going to be the revenue minus the costs. So in order to do this, we would like to be very careful and combine like terms. So let's start out with the revenue, negative 0.02 x squared plus 150x minus the cost. So minus the cost, and I'm going to go ahead and move this down to the next line and say minus the cost on this next line so that we actually have space for it. Oh, except now I can't see it. There we go. So we got a 0.123451 x cubed and minus 0.01 x squared, a plus 50 x, and a plus 20,000. Now we're going to make sure we distribute this negative. Whoops. To each term. We don't want to drop that negative from any of those terms. And we want to group like terms. So the first thing I'm going to see is that this negative times this first term gives me the highest power of my exponent. So I'm going to go ahead and write that as negative 0.0003451 x cubed. And then I have an x squared term. So I have minus 0.02 x squared. And this negative times this negative is plus 0.01 x squared plus 150x. And I could have written it underneath. I'm going to use this minus 50x here. And then I have a minus 20,000. So simplifying this, the tiny teeny bit that we're able to, is to make this, combine these two terms. So we have minus 0.02 plus 0.01, that's going to be minus 0.01. You could do that on a calculator if you are not comfortable doing it that way. 150 minus 50 is plus 100x, and then minus 20,000. Okay, so now we have our profit function. And the last question we're asked is, what is the profit for the company if 2,000 units are produced and sold each week? So that's just simply saying, what's the profit for 2,000? So if we put this in here, we get minus 0.000345 times 2,000 cubed minus 0.01 2,000 squared plus 100 times 2,000 minus 20,000. So go ahead and put that in your calculator. If you did, hopefully what you got was, let me do that. So we got 2,000, and we're going to cube it, and looks like we're going to get 8 billion, and we're going to multiply that by 0.000001 negative, and I get negative 8,000 for that first term. And then for the next term, I have 2,000 squared times 0.01, and I get 40,000, so I'm going to subtract 40,000. I'm going to do 2,000 times 100, and I get 200,000. And I'm going to subtract 20,000 from that. So if all my math is right, then I'm going to have 8,000, negative 8,000 minus 40,000 plus 200,000 minus 20,000, or $132,000 profit. The next problem that we need to work on is problem number 12. And problem number 12 says, that a study prepared for the National Association of Realtors estimated that the number of housing starts per year over the next 5 years will be given by this function, capital N of R. And it's a function involving radicals, and this is given in million units, where R is a percent and it represents the mortgage rate. Suppose that the mortgage rate T months from now will be given by R of T, which is also given by a function that's a quotient. And we are told that this is thought to hold up until T between 0 and 24 months from now, or 2 years. And R is, the output of this is in percent per year. So the first thing we're told is find an expression for the number of housing starts per year as a function of T months from now. Okay, so let's go ahead and translate this over to where we're working on this. Okay, so looking at problem 10, we're told that N of R is equal to 7 divided by 1 plus 0.02 r squared. Okay, so let's talk about the input and the output on this. So the input is R. And what is R? R is the percent of the mortgage rate, is the mortgage rate. Okay, and what's the output? So the output is what this ends up being after we put in the input of the mortgage rate. N is the function output, and that N is representative of the number of housing starts. Okay. The next thing we're told is that the mortgage rate as a function of time in months will be given by this function, 5t plus 75 divided by t plus 10. And this is for t up to 24 months from now. So now let's look at this. What's our input? Our input is time in months. And what's the output? Is a mortgage rate of housing starts per year as a function of t months from now. So we see that we can link these functions because the output of this function is the input to that function. So we're able to do a composite of n circle r. And we end up with the units of our input from our first function. And that's exactly what we want to do. So we're going to say n of r of t. Well, what's r of t is this function right here. So we're going to introduce that to our function. It's going to be, I'll go ahead and put it in green, 5t plus 75 divided by t plus 10. And what does our function n tell us to do? It says you're going to put that whole input, and it's going to only go right here in this r squared spot. So we're going to say it's 7 divided by 1 plus 0.02 times 5t plus 75 divided by t plus 10. Oh boy, so that's a kind of a mess. Let's see if we can clean that up a little bit. Okay, so let's go ahead and start out with saying this whole thing. Well, let's just take this one step at a time. The top is still 7. The bottom is 1 plus. Now let's go ahead and multiply this 0.02, and we're going to think of it as divided by 1. We're going to multiply the numerator across the top and the denominator across the bottom. So we're going to multiply the 0.02 times the 5t and times the 75. Okay. So 0.02 times 5 is going to be 0.1, right? So 2 times 5 is 10, and there's 2 decimals. And you can check that if you'd like on your calculator. So we're going to have a 0.1 t, and then 0.02 times 75. And I believe that will be 1.5. So plus 1.5. And then the denominator is just t plus 10. Okay. So now the next thing we're going to want to do is we're going to want to convert this 1 into a disguised form of 1. We want to have a common denominator, so we're sort of ignoring the top for now. Okay, we're just ignoring the numerator. We're focusing just on the denominator, and we're treating it as a mixed fraction that we need to fix and straighten out and get it into one total one fraction. So let's go ahead and take this 1, and we're going to have to carry the numerator along for the ride. So we're just going to write as this is t plus 10 over t plus 10 plus 0.1 t plus 1.5. Oops, I got a little sloppy. And this whole part here is over t plus 10. Alrighty, and if you want, you can put parentheses around it just to be super clear. Now we have a common denominator. So what we're going to be able to do now is, again, we haven't dealt with the numerator yet. It's just coming along for the ride. But for the denominator, we have t plus 0.1 t, so 1.1 t, right? And 10 plus 1.5, so that's 11.5, divided by t plus 10. So when you have something that is a number divided by a fraction, right? This is equal to that same number times the reciprocal of the denominator, right? So we can write this whole thing, so that's just a reminder that we can write this whole thing as 7 times the reciprocal of the denominator. So we have t plus 10, and in the denominator we have 1.1 t, and I'm going to put parentheses around it just to be clear, plus 11.5. And if we do that, we find an expression. So there's one more step we can do to kind of simplify this a little bit more. We can write this as 7t plus 70 by distributing that 7 to each term in the numerator and dividing now by, we just keep the denominator, right? Because this is like 7 times 1, and we multiply across, so this 1.1t plus 11.5. Okay, so that's our answer. We still have that domain restriction, and we can write that domain restriction as the closed interval 0 to 24. So this is out to 2 years. Also need to consider that the denominator of this function could possibly be 0 within our domain of 0 to 24. And if we do the math, when is 1.1t plus 11.5 equal to 0? If you subtract 11.5 from both sides, you'll have a negative 11.5 divided by 1.1. And that comes out to a negative 10.45455. But that is not included in this 2 years. Okay, so now we're asked in Part B to use the results from Part A and determine the number of housing starts at present and 12 months from now. Okay, so at present would be the number of housing starts. And remember now this is a function of t because we've done a, I should do t circle r. So our new function is a function of t. Just to remind you that this is where we were at. We were getting the composition of the number of housing starts that was a function of the mortgage rate, and the mortgage rate, which was a function of time. We put it all together and we came up with this function over here, right? So this is what we're going to now use to answer the question. So we actually want to ask the question now, and now is considered when this function is applicable. So it's between now and 24 months from now. So we're going to now is at month 0. So if we put this in, we find that 0 is included in domain, so we're okay there. And we go ahead and we put it as, and we get 7 times 0 plus 70 divided by 1.1 times 0 plus 11.5. Okay. Well, 7 times 0 is 0, 1.1 times 0 is 0, times 0 is 0. So we just have 70 divided by 11.5, and that we can put in our calculator, and we can find the answer. So 70 divided by 11.5 is 6.08 to a whole bunch more decimals, and it rounds actually to 6.09. So roughly we will have 6. Now if you go back and you read the way the problem was worded, the number of housing starts per year over the next 5 years in millions of units. So we would expect that this month, there is going to be, so right now, so this month there would be approximately 6.09 million units started. Then we want to know, what about in 12 months from now? According to this mortgage function and this this function for the number of units based on that mortgage function, where would we be in 12 months? So that is this function that's now converted to time, given out to 12 months, and we're just going to have to put that into our formula. So it's 7 times 12 plus 70 divided by 1.1 times 12. If you want to put parentheses, maybe that makes it cleaner, plus 11.5. All right. So if you are doing this on a scientific calculator where you can put parentheses, then go ahead and do that. If not, what you may want to do is actually just write out what the numerator and denominator are. So 7 times 12 plus 70 gives me 154. And then for the denominator, we have 1.1 times 12 plus 11.5, or 24.7. And then if we take 154 and we divide 24.7, we end up with 6.23. So we see a slight increase, and we say that in 12 months, these models expect there to be 6.23 million units started. And by units started, they mean housing starts. So they mean the beginning of a house or an apartment. In that month. So that's the number of houses or units. I'm not sure what they call a unit. It might be in a condominium may count as well. The number of units started in that month.